All right, so guys, this is number 9 out of 4.1. And so the problem here says in a game of roulette, a player can place a $4 bet on the number 18 and have a 1 in 38th probability of winning. If the metal ball lands on the number 18, the player gets to keep the $4 paid to play the game, and the player is awarded an additional $140. Otherwise, the player is awarded nothing, and the casino takes the player's $4. Find the expected value EX to the player for one play of the game. If X is a gain to a player in a game of chance, then E of X is usually negative. This value gives the average amount per game that the player can expect to lose. Okay, so this problem has a lot of info, and I think part of it could be, some of us may not necessarily be familiar with roulette, but roulette it's a wheel, and there's 38 slots, and there's red and there's black, and some of those red and black slots have numbers. Okay, so and those numbers are actually going to be 1 through 38. So if you could imagine, like this is like a pizza, right? And I'm going to cut it into 38 equal slices, right? So I'm going to be here for a long time. I'm obviously not going to do it all, but it would look something like that. Okay, and then they drop a little ball, and this thing is spinning, and then sometime the ball's going to land. Oops. The ball's going to land on one of those slots, okay? So what we're going to do is we're going to figure out what's the probability that we're going to win. Okay, so I'm going to put P of W like probability that I'm going to win. Well, the ball's only going to land on one of those things, and because there's 38, my probability of winning would be 1 out of 38. Now, what's the probability that I'm going to lose? Well, 37 out of 38, right? Because there's still 37 other slots. Okay, so now the way we're going to figure out our expected value E of X, says, if I win, what's the probability I'm going to win? The probability I'm going to win is 1 out of 38. Now, if I win, there's a prize associated with that. Well, if I win, I get $140, right? But remember, in order to play the game, I actually had to spend how much? I had to spend $4. So I don't really win 140. I really win 136. So I'm going to put this over 1 because I have fractions here, okay? Now, I might lose. And if I lose, the probability I'm going to lose is 37 out of 38. And if I lose my $4. Now, because that's a loss, I'm going to consider that a negative 4 over 1, okay? And so now my expected value, I'm just going to multiply straight across. This is 136 over 38. And this is going to be a negative. I know the bottom's still going to be 38. I'm just going to use my calculator on my phone here, guys. I'm just going to multiply 37 times 38. I don't think you guys need to see that part. 37 times 4, negative 148. So here's my negative 148, okay? There's still a 38 right here. And now I'm just going to subtract the numbers on the top. So 136 minus 148 leaves me with a negative 12. And now I'm going to go ahead and convert that to a decimal. So negative 12 divided by 38 is a negative point. On my calculator, you know what? I'll actually show you that part there so you can see what I'm talking about. So here we go. Let's clear that out. So we said negative 12 divided by 38. And let me make that into a decimal so y'all can see what I'm talking about. Okay, so you can see here I'm coming up with negative 0.3157, right? This is in terms of money. So in terms of money, I need a round, right? So instead of negative 0.31, I'm going to say negative 0.32. And so my answer here is equals negative 0.32 cents. So what this means is, on average, if I were to play this game a whole bunch of times, right, there's going to be times that I'm going to win, there's going to be times that I lose. But if I play this over and over and over and over and over again, with my winnings and my losses, if you were to average them out, you would say, well, on each time, on average, I lost negative 30, or I lost 32 cents. That's why it's a negative 0.32. Anyway, I hope that helps. If y'all got any questions, please let me know. I'm happy to help you guys, okay?